Hi everyone, today we are going to be wrapping up the boot camp talking about chemical reactions, specifically aqueous chemical reactions, which are reactions that can occur in water. And we're going to be talking about 3 different types of reactions here. We're going to be talking about our solubility rules, how to write reactions from scratch, and I know that there's a lot on this page here, so let's not get overwhelmed. Let's kind of break it down. First of all, if you've gone through the PowerPoints for Module 6, you've seen that this is straight out of Module 6. You've seen that we talk about 3 types of chemical reactions: precipitation reactions, neutralization reactions, and oxidation reduction reactions. Today on this video, I'm going to focus on precipitation reactions, which are essentially when a solid that is also known as a precipitate, that's why it's called precipitation reaction, forms from the combination of 2 solutions. The key to writing a precipitation reaction and knowing that it is a precipitation reaction is really internalizing your solubility rules. The question you need to ask yourself is does the combination of compounds in this reaction, the combinations of anions and cations, do they form insoluble compounds? A solid or a precipitate only forms when something is insoluble. And we'll go through some examples. These are our solubility rules right here. Take a picture of them, look at them on Module 6, really know them for the fall because they are absolutely essential in writing precipitation reactions. If we're looking at this example 4.9 here, this huge chunk of stuff, this is straight out of your textbook for the fall. And the example is predicting whether an ionic compound is soluble. Remember, for something to be soluble, it means it's not a precipitate, so it's not a solid. It's going to be, the state is going to be aqueous. If something is insoluble, the state is going to be solid. And then we have a precipitation reaction because it essentially precipitates or falls out of the reaction as a solid. It doesn't dissolve. So predict whether each compound is soluble or insoluble. You can pause the video here and look through the explanations here for A, B, C, and D. Essentially, we have lead, PbCl2, lead 2 chloride. And if we look at our solubility rules here in this table, we essentially see that if we're looking for things that are insoluble, we don't see lead here. So we know that lead is most likely going to be soluble. If we're looking at things that are soluble, we see chloride here. And it says when it contains ions of silver, mercury, or lead 2+, the resulting compounds are insoluble. So I misspoke before seeing chloride. But if we see silver chloride, if we see a mercury chloride, if we see lead 2 chloride, all of these are going to be insoluble, okay? If we see sodium chloride, this is going to be soluble because it's not listed there. So, the answer explains that it's insoluble because compounds containing Cl- are normally soluble, but lead 2+ is an exception along with mercury and silver. B, for copper 2 chloride, we see that if we're looking at chloride here, we see that the only things that are insoluble when paired with chloride, like we just mentioned, silver, mercury, and lead, there is no copper, which leads us to believe that by default, it's going to be a soluble compound. For C, we have calcium nitrate. Let's give it a look. Let's look for nitrate here. You know, things with nitrate, it says, are generally soluble. What are the exceptions? Nothing. So any element paired with nitrate is going to be soluble. So, C, soluble. We have barium sulfate. Let's look at sulfate here. What are the exceptions? Things with sulfate are generally soluble, but if sulfate is paired with strontium, barium, lead, silver, or calcium listed here, it's going to be insoluble. Anything else, sodium sulfate, is going to be soluble. Since calcium is listed there, we know it's insoluble. If we're looking at A, B, C, and D here, and maybe these were our only products of a chemical reaction, which would be unlikely, but if these were our only products, that would mean that we had a precipitation reaction for A and D, because like I said, precipitation reactions only occur when you have a compound that is insoluble and is in the solid state. Insoluble means solid state. Soluble, it would be AQ, aqueous. Try this for practice 4.9 on your own. Let's actually go ahead and do number 73 really quick. This is about a precipitation reaction. Write a molecular equation for the precipitation reaction that occurs, if any, when each pair of aqueous solutions is mixed. When it says if any, a reaction, like we said before, a precipitation reaction does not occur if there is not a insoluble compound produced. If there's not an insoluble compound in the solid state. If every compound is soluble that it produces, no precipitation reaction occurs. So let's just start with A and B and see if you guys can do C and D on your own. We have potassium carbonate, which I believe carbonate is, oops, sorry, that's a little messy. Carbonate is a 2- charge, so it's going to be K2CO3 plus lead nitrate. It's going to look like this since lead is a 2 charge. Now it wants us to write the products. The key for a precipitation reaction here is we're going to look at the first element or the first ion in both the compounds, and these are going to pair with each other. These are going to pair with the other ions of the opposite compound on the right side. So they're going to flip-flop here, essentially. And that means we are going to have KNO3 plus PbCO3. And since carbonate is a 2- and lead is a 2+, they're going to cancel each other out. So it's just going to be PbCO3. Like I said here, again, we're writing a precipitation reaction. Let's flip. So this, let's do a different color, sorry. This goes with this, and this goes with this. So the second ion and the first ion of the two different compounds go together, and the first ion and the second ion of the two different compounds go together. Let's look really quick at the products. KNO3, potassium nitrate. Let's look at our solubility chart. So we see that nitrate is normally soluble, and there's no exceptions, right? So that means that potassium nitrate has to be soluble. What does that mean for the state? It's aqueous. It's not a solid because it's soluble. Lead carbonate. Carbonate is generally insoluble. Are there any exceptions here? Yeah, there's lithium, sodium, potassium, and ammonium, when they pair with carbonate, are soluble. You have to look at that. Some say insoluble, some say are soluble, which means that everything else besides this lithium, sodium, potassium, etc., are insoluble when paired with carbonate, because carbonate is generally insoluble. Is lead listed there? It is not, which leads us to believe that lead carbonate is going to be a precipitate. It's going to be solid because it's insoluble. And a precipitation reaction does occur in this case. Let's look at B. We have lithium sulfate and lead 2 acetate. Okay. If I'm writing this out, lithium is a +1 charge, and sulfate is SO4 2 minus. So we have lithium 2SO4 because we're going to do the drop down method, which basically is this drops down here and this charge drops down here. We have lead to nitrate. Oh, sorry, I'm reading the one above. Lead to acetate. Acetate, I always forget what it's written as. Let's see if it lists it. It's right here, C2H3O2. That was one that was always hard for me to remember. But acetate's a -1 charge, and lead is clearly a 2+ charge, like the previous example. If we drop down the charges to the opposite sides, we get, there's a parentheses around acetate because it gets that 2+ charge from lead. If we're looking at the products that are formed, let's find out if a reaction even occurs. If we have two products that are AQ, no reaction occurs. How do we know what the products are going to be? The first ion from the left side and the second ion from the right compound are going to pair together. Then the second ion the first ion, lead, and then the second ion are going to pair together. So just a little flip-flop situation. Let's look at our products. Lithium acetate. Both have a 1 charge. Acetate has -1, lithium has plus charge, so there's going to be no little subscripts there. Lead is a 2+ charge, sulfate is a 2- charge. So it's just going to be simply lead sulfate here. Let's look at our solubility chart. Acetate, like I circled, is normally soluble. Wow, I keep mixing up my words. What are the exceptions? If acetate is paired with lithium, like in this case, what are our exceptions? None. That means that it is pretty much going to be soluble in any case. What's the state? It's AQ. It's not solid because no precipitate is formed because it's soluble. Let's look at lead sulfate. Sulfate, again, is pretty much always soluble except for some exceptions. The exceptions are strontium 2+, barium 2+, lead 2+, silver, and calcium. So we know that when paired with sulfate, lead makes a precipitate, it makes a solid, it's insoluble. Does a reaction occur? Yes, it does, because we have at least one product that is insoluble. That's it. That's all I have for today, you guys. Look at example 4.9, pause the video if you need. These are some more for practice problems right here for you. You can always finish C and D and come to my office hours if you need further clarification on how to write a precipitation reaction and how to determine whether something is soluble. Thank you, guys.